So welcome back. So we have seen for now several kinds of types, records, tuples, arrays, and to understand them better, we will use them together in a single program. This program will be a toy database that will handle a contact list for three kinds of queries: the insertion of a contact, the removal of a contact, and a lookup function in the database. So the type of this function will be the following one. You will take a database, a query, and return a triple composed of a status, a database, and a contact. So the status will be true if the query went well. The second component, the database, will be a new database if we have inserted or deleted some contact. And finally, if a contact has been found, it will be found in the third tuple component of this tuple. So let us define a type for phone number and another type that will relate a name with a phone number. It is easy to define a stupid record for a contact with an empty name and a phone number consisting only on 0. Then a database will be represented by two fields. The first one represents the number of contacts, and the second one is an array that contains the contact. If you want to make a database, you take as argument the maximum number of contacts that you will store in your database. At the beginning, the number of contacts is 0, and you have to initialize to create an array whose size is the maximum number of contacts of your database. And for the moment, all the elements are equal to nobody. Now, a query will be represented by a code, one integer for each kind of query, and sometimes you need to give a contact when you do a lookup function. So we also have a field to represent a contact. Here is a function that takes a database, a contact, and looks for this contact in the database. It is pretty simple because you just have to go through the array, and if you find a cell whose name is equal to the name of the contact that you are looking for, then you return a triple saying that the lookup was a success. The database can be returned as is, and the important information is the contact that you have found, which is located at the position EDX. Otherwise, maybe you are at the end of your database. If your index is superior to the number of contacts that you have in your database, or maybe you can go to the next index by doing a recursive call with an incremented index. Now, if you want to insert a contact in the database, so first let me input this in the system. If you want to insert a new contact in the database, then there is the first case. If you have reached the limit of contacts that can be stored in the database, so that means that the array is full, so the number of contacts is equal to the length of your array, then you produce an error by saying that the status is equal to false. Otherwise, you have to first search if the contact is already in the database, and in which case you also produce an error. And finally, if the contact is not in the database, then we will create a new database in which the cells are defined using this function cells. So if the index is equal to the number of contacts, then we will use this index to store our contacts. So we return the contact that we want to insert. Otherwise, we just don't change the content of the initial database, so we return the current value of the array at position I. You have to create a new database with the new contact inserted. The number of contacts is now the number of contacts plus 1, and the array containing the contacts is a new array whose cells are initialized using the function cells. And this time the status is true, the new database is DB prime, and you can return the contact that you have inserted, for instance. You can do the same to delete a contact. You can just first search for the contact. If it is not in the database, then you return an error. Otherwise, you just have to recreate the same database, except that now the number of contact is the number of contact minus 1, and the new array is initialized using a cells function, so that if you are defining the cell for the contact you want to delete, then you return nobody. So it's a way to erase this cell. And if the contact you are considering is not the contact you want to remove, you just return the same contact as the one you can find in the initial database. So we have implemented our 3 features for the database, and we can now implement the engine function. It takes the database and the query. Depending on the value of the code, we will do an insertion if the code is equal to 0, a deletion if the code is equal to 1, and if the code is equal to 2, we do a search, and we use the context that is provided as argument to perform the query. Otherwise, we have an invalid code, so we return an error. So this function is just a way to glue together the 3 functions that we have defined previously. So let's now define a database of size 5. We can add a new contact for Luke, another contact for Darth Vader. We can search for Luke, and indeed it is found, and you get the contact here. You can remove Luke from the database, and we can see that now the database only contains Darth Vader. And finally, if you look into the database again for Luke, you get an error. The status is equal to false, which means that there is an error. If we compare the implementation that we have just done for our database engine with an imperative one, what is clear is the fact that we have written a non-destructive program. Indeed, when we look back at the type of this database engine, we can notice that a new database is created each time a query is processed. So previous versions of this database are still available as valid values in OCaml. In contrast, when you do an imperative programs and you apply a query to a database, this modifies the database in place. In fact, what we have programmed is a purely functional database engine. So now, what does it matter? Why side effects are considered harmful to the purely functional programmer? Well, The idea is that when you do program in a functional language, you try to produce values instead of modifying the memory. And what you get is something that does not depend on the state of the program, but only on the argument of the function. And this is exactly like in mathematics. You can call a function several times, and on the same input you will get the same output. So it is easier to reason on functional programs, and it is easier to specify them using mathematical objects. For instance, a valid specification for our engine is the fact that if you insert a contact in a database and just after that you delete it, then you get a database which is exactly the same one that you gave initially. As it does not depend on the state of the machine, a functional program can be used anytime. That means that it is more composable, it can be adapted to more contexts than an imperative one. So now, what are the weaknesses of our implementation? Well, the specification that we have assigned to our engine is not very satisfying. Indeed, search queries should return a contact, while insertion queries should return a database. But the type that we have assigned to engine forces us to use a single type of query results. So you have to return a database when you do a search query and a contact when you do an insertion query. Instead, we would like to say that the type of the engine is either a contact or a new database. Another problem is the fact that when we create a new database, the database is duplicated entirely, even if almost everything in the database is the same as in the previous database. We should use a better data structure to represent the database to enable more sharing between the different versions of the database. The forthcoming algebraic data types that we will discover next week will be an elegant answer to all these problems.